So what's the deal with quality? What's the secret sauce that makes some things work perfectly every single time? Well, today we're pulling back the curtain on the hidden system that makes consistency possible. You know the feeling, right? You buy something, it's amazing, you recommend it to everyone, then you buy it again, and it's just not the same. It's so frustrating. What separates that reliable go-to product from the one that's a total roll of the dice? Well, it turns out there's a very specific answer. And that answer is something called process control. It sounds kind of technical, but trust me, the idea is super simple and super powerful. We're going to break it all down for you today using the incredible work of author Mohammed Ajloni as our guide. By the end of this, you're going to see this concept everywhere. Okay, so to really get a grip on process control, we've got to start with the absolute basics. Let's talk about what a process even is and how it's connected to a product. Think about it like this. At its simplest, a process is just a system that takes something in, does something to it, and spits something else out. You know, like a factory machine. You put raw materials in one end, the machine does its thing, and a finished product comes out the other. That's a process. This diagram right here, this is the key to, well, everything we're talking about today. You've got your inputs on the left, the process in the middle, and the outputs on the right. This simple flow is our roadmap for understanding quality, so really let this one sink in. Now that output, the final product, it has to be good, right? It needs to meet certain standards or specifications. Sometimes these are dictated by what you, the customer, actually wants. Other times, they're internal quality goals that the company sets for itself. So if a product has all these different features and characteristics, how in the world do you know which ones to focus on? That brings us to a really important idea. We zero in on what are called critical to quality characteristics, or CTQs for short. Now, these aren't just random measurements. These are the things the customer really cares about, the make or break features. If these are off, the customer is not going to be happy. So these are the things we absolutely have to control. And for every single one of those CTQs, we define what are called specification limits. Just think of it like a bullseye. As long as your product's quality lands somewhere inside that target, you're good to go. But the moment it falls outside those limits, you've got what's called a non-conforming product, or, a defect. Okay, so we know we need to hit that target with our final product. But how do we make sure that happens consistently? To answer that, we have to rewind all the way back to the beginning of our model, the inputs. Now, this is a super important distinction that Mohammed Ajloni points out. Not all inputs are the same. On one hand, you have process parameters. Think of these as the dials and settings you can literally turn on a machine. On the other hand, you've got process conditions, which is more about the whole environment the process happens in. So to make that a little more real, process parameters are the hard numbers. Things like the exact temperature you're running at, the amount of pressure in a system, how fast a mixer is spinning, or the flow rate of a liquid. These are the levers you can pull directly. Process conditions, that's the bigger picture, and there's a handy way to remember them called the 4 M's. You've got man, which means the people running the show, material, the raw ingredients you're using, machine, the state of the equipment itself, and finally method, the exact procedures everyone is supposed to follow. So we've got all these inputs, parameters, conditions, all feeding into our process. But there's a ghost in the machine. There's a fundamental problem that lurks behind every single one of them. Because here's the thing, no matter how hard you try to make everything perfect, every single one of those inputs, every temperature setting, every raw material, every action a person takes is subject to variation. That's the enemy. That's the core problem. A dial set to exactly 100 degrees might actually flicker between 99.9 and 100.1. One batch of raw material might be slightly different from the next. No two people perform a task in the exact same way every single time. Variation is natural, and it is everywhere. And this brings us to the single most important idea in this entire explainer. Variation in your inputs directly leads to variation in your outputs. It's a fundamental law. If the stuff going into your process is unpredictable, the product coming out is going to be unpredictable too. Simple as that. So if variation is the enemy, how do we fight back? Well, the good news is there is a very clear 2-part strategy. Let's get into the solution. The strategy is a 2-pronged attack, one for each type of input. For those technical process parameters, like temperature and pressure, we use automated systems like thermostats and sensors to keep them locked in. And for the bigger picture stuff, the 4Ms, we rely on having really clear, really strict standard operating procedures, or SOPs. But, and this is a huge but, it's not enough to just write the rules down and hope for the best. You have to check that people are actually following them. That's why regular audits are so critical. They make sure everyone and everything is staying on track. So, if you're going to remember just one thing today, let it be this. At the end of the day, effective process control is not some dark art. It's the simple, disciplined work of hunting down and crushing variation in your inputs so you can guarantee a consistent quality output. Now, in a factory setting, this makes perfect sense. But I want you to think bigger for a second. What about baking the perfect cake, or training for a marathon, or even just being more productive at work? It always comes down to managing your inputs, doesn't it? So I'll leave you with this to chew on. Where in your life could controlling the inputs lead to a much, much better output?